We have discovered a new element called ethiopium. We found out that the atomic number is 132 and the atomic mass is 347.95. We also know that the chemical symbol is Em.
Because we know our element's atomic number is 132, we know it is located right here on the periodic table. So its electron configuration starts at 1s2, then to 2s2, then to 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s2, then to 4f14, then back to 5d10, to 6p6, to 7s2, then to 5f14, back to 6d10, to 7p6, then we added 8s2, 7d10, and 8p2 is the last block for our element. Next, we figured out ethiopium's noble gas electron configuration, which starts at oganesson, then to 8s2, then to 7d10, and then 8p2. All of the superscripts of this electron configuration should add to 132 at the end to get ethiopium's atomic number.
Lewis dot structure shows the number of valence electrons an element has. Since we know that ethiopium is in group 14 or 4A, it has 4 valence electrons, which you can see are modeled here.
Ionic bonds happen between metals and nonmetals. We know that ethiopium is a metal because it has 4 valence electrons, and on the periodic table it is under the metalloid stair step. The metal is giving away electrons to the nonmetal, which is gaining electrons. So because chlorine only has 7 electrons, it needs 1 to fill the octet rule. And Em has 4 valence electrons, so it gives 1 to each of the chlorines. We know that this is the equation for that ionic bond because the metal goes first, and it says plus 4 because it's getting a positive charge because it's losing electrons. There are 4 chlorines, and they have a negative charge because it's gaining 1 electron and has a full octet around it. Okay, in this equation, sulfur has 6 valence electrons and needs 2 to fill the octet rule. So Em has 4 valence electrons to give. So it gives 2 to the first sulfur and 2 to the second sulfur. We write this equation with the metal going first, and it is losing electrons, so it's getting a positive charge, plus 4 because it got rid of 4 of them. There are 2 sulfurs, so the coefficient 2 goes in front, and it got all valence electrons and gained 2, so it has a negative charge. Em has 4 valence electrons to give. Oxygen has 6 valence electrons already and only needs 2 to fill into the octet rule. Em gives first 2 valence electrons to the first oxygen and their second 2 valence electrons to the second oxygen. Because it's a metal, it goes first. It has a positive charge because it got rid of 4 valence electrons. It has a coefficient of 2 because there are 2 oxygens, and it has a full octet and gained 2 electrons, so it has a negative charge.